Welcome to our deep dive into the world of filtration in chemistry. Filtration is a fundamental separation technique used in laboratories and industries alike. It allows chemists to separate solids from liquids or gases using a barrier, typically called a filter. This process is crucial for purifying substances, isolating products, and ensuring accurate experimental results. In this video, we'll explore how filtration works, its various types, and real-world application. Whether you're a student, a science enthusiast, or just curious about chemistry, understanding filtration will give you valuable insight into how mixtures are separated and purified. Let's begin our journey by understanding the basic concept of filtration. Filtration is a physical process used to separate particles from fluids, either liquids or gases, by passing the mixture through a filter. The filter acts as a barrier, allowing only the fluid to pass through while trapping the solid particles. This technique is widely used in chemistry labs to purify compounds, remove impurities, or collect precipitates formed during reactions. The effectiveness of filtration depends on the size of the particles and the type of filter used. Understanding this process is essential for anyone working in a laboratory setting, as it forms the basis for many experimental procedures. Filters are the heart of the filtration process. They come in various forms such as filter paper, membranes, or even sand beds depending on the application. The choice of filter is determined by the size of the particles to be separated and the nature of the mixture. For example, filter paper is commonly used in laboratories for simple liquid-solid separations, while more advanced filters are used in industrial settings. The filter must be porous enough to let the fluid pass but fine enough to trap unwanted particles. Selecting the right filter ensures efficient and effective separation. Gravity filtration is one of the simplest and most common methods used in chemistry labs. In this process, the mixture is poured onto a filter paper placed in a funnel. Gravity pulls the liquid through the filter, leaving the solid residue behind. This method is ideal for separating large visible particles from a liquid. It's often used when the solid is the impurity and the liquid is the desired product. Gravity filtration is straightforward, requires minimal equipment, and is perfect for quick, routine separations in the lab. Vacuum filtration is a faster and more efficient method compared to gravity filtration. Here, a vacuum is applied below the filter to pull the liquid through more quickly. This technique is especially useful when dealing with fine particles or when a rapid separation is needed. Vacuum filtration typically uses a Boucher funnel and flask along with filter paper. It's commonly employed when the solid is the desired product, such as in crystallization experiments. The vacuum ensures that even small particles are effectively separated from the liquid. Filtration isn't just limited to chemistry labs. It's a process we encounter in daily life. For example, coffee makers use filters to separate coffee grounds from the liquid, and air purifiers filter out dust and allergens. Even water treatment plants rely on filtration to remove impurities from drinking water. These everyday examples highlight the importance and versatility of filtration as a separation technique. Understanding the science behind these processes can help us appreciate the technology that keeps our lives clean and safe. Every filtration setup consists of a few key components: the filter medium, the support structure, and the collection vessel. The filter medium is the material that actually separates the solid from the liquid. The support structure, such as a funnel or filter holder, keeps the filter in place, while the collection vessel gathers the filtered liquid known as the filtrate. Each component must be chosen carefully to ensure the process runs smoothly and efficiently. Proper assembly of these parts is crucial for successful filtration. Filters work by providing a barrier with pores small enough to block solid particles but large enough to let fluids pass through. The size and distribution of these pores determine what gets trapped and what passes through. In some cases, filters also use chemical or electrical properties to enhance separation. For example, activated carbon filters can adsorb certain chemicals, making them useful for purifying air or water. Understanding how filters function helps in selecting the right type for each application. Selecting the appropriate filter depends on several factors, including the size of the particles to be separated, the nature of the mixture, and the desired speed of filtration. For coarse particles, a simple filter paper may suffice. For finer particles or more demanding separations, specialized membranes or vacuum filtration setups might be necessary. It's important to match the filter's properties to the specific requirements of the experiment to achieve the best result. Filtration is just one of many separation techniques used in chemistry. Others include distillation, centrifugation, and chromatography. Each method has its own strengths and is suited to different types of mixtures. Filtration is best for separating insoluble solids from liquids, while distillation is used for separating liquids with different boiling points. Understanding when to use filtration versus another method is a key skill for any chemist. Typical laboratory filtration setup includes a funnel, filter paper, and a flask to collect the filtrate. The filter paper is folded and placed in the funnel, which is then set above the flask. The mixture is poured into the funnel, and gravity or vacuum pulls the liquid through the filter. Proper setup is essential to prevent leaks and ensure efficient separation. Attention to details such as wetting the filter paper before use can make a big difference in the outcome. Folding filter paper correctly is an important step in preparing for filtration. The most common method is to fold the paper into a cone shape, which fits snugly into the funnel. This maximizes the surface area for filtration and ensures that the liquid flows evenly through the paper. Proper folding also helps prevent spills and ensures that all the solid particles are trapped. Mastering this simple technique can improve the efficiency and cleanliness of your filtration process. Industrial settings, filtration is used on a much larger scale. Factories use massive filters to purify chemicals, treat wastewater, and produce clean air. Industrial filters are often made from durable materials and designed to handle high volumes and pressures. The principles remain the same as in the lab, but the equipment is scaled up to meet the demands of large-scale production. Filtration ensures product quality and environmental safety in many industries. Membrane filtration uses thin, porous membranes to separate particles from fluids. These membranes can filter out extremely small particles, including bacteria and viruses. This technique is widely used in water purification, pharmaceuticals, and food processing. Membrane filtration offers high precision and can be tailored to specific needs by choosing membranes with different pore sizes. It's a powerful tool for achieving ultrapure products in both laboratory and industrial settings. Water treatment plants rely heavily on filtration to provide safe drinking water. Multiple stages of filtration remove dirt, bacteria, and other contaminants from raw water sources. Sand filters, activated carbon, and membrane filters are commonly used. Each stage targets different types of impurities, ensuring that the final product is clean and safe for consumption. Filtration is a critical step in protecting public health and maintaining water quality. Air filtration systems are essential for maintaining clean indoor environments. These systems use filters to trap dust, pollen, and other airborne particles. In chemistry labs, specialized filters remove hazardous fumes and chemicals from the air, protecting both people and equipment. High-efficiency particulate air HEPA filters are especially effective at capturing tiny particles, making them a popular choice in hospitals and clean rooms. Food industry uses filtration to ensure product quality and safety. For example, milk is filtered to remove impurities before pasteurization, and juices are filtered to achieve clarity and improve taste. Filtration also plays a role in brewing, winemaking, and oil production. By removing unwanted solids, filtration helps create products that are both appealing and safe for consumers. Pharmaceutical manufacturing relies on filtration to produce pure and effective medicines. Filters remove contaminants from raw materials, separate active ingredients, and ensure that final products are free from harmful particles. Sterile filtration using ultrafine membranes is critical for injectable drugs and vaccines. This process helps maintain the highest standards of safety and efficacy in the pharmaceutical industry. Environmental scientists use filtration to monitor and protect ecosystems. By filtering samples of air, water, or soil, they can detect pollutants and assess environmental health. Filtration helps identify sources of contamination and track changes over time. This information is vital for developing strategies to reduce pollution and safeguard natural resources. In analytical chemistry, filtration is often the first step in sample preparation. Removing solid impurities ensures that subsequent analyses are accurate and reliable. Whether testing for contaminants, measuring concentrations, or identifying unknown substances, filtration helps produce clear, uncontaminated samples for precise results. Microbiologists use filtration to isolate and study microorganisms. Special filters with tiny pores can trap bacteria, viruses, or fungi from liquid samples. This technique is essential for research, diagnostics, and quality control in food and pharmaceutical industries. Filtration allows scientists to concentrate and analyze microbes that would otherwise be difficult to detect. Crystallization is a common method for purifying chemicals, and filtration plays a key role in this process. After crystals form, filtration separates them from the remaining liquid known as the mother liquor. This step ensures that only pure, solid crystals are collected. Vacuum filtration is often used here to speed up the process and improve yield. During precipitation reactions, an insoluble solid forms in a solution. Filtration is used to separate this solid, called the precipitate, from the liquid. This technique is essential for isolating products in inorganic and analytical chemistry. Proper filtration ensures that the precipitate is collected efficiently and that the remaining solution is free of solid particles. Organic chemists use filtration to purify reaction mixtures and isolate products. After a reaction, the mixture may contain solid byproducts, catalysts, or unreacted materials. Filtration removes these impurities, leaving behind the desired compound. This step is crucial for obtaining pure samples for further analysis or use. The oil and gas industry uses filtration to remove solid contaminants from crude oil and natural gas. This process protects equipment, improves product quality, and ensures safe operation. Specialized filters are designed to handle high pressures and temperatures, making them suitable for challenging industrial environments. Mining operations use filtration to separate valuable minerals from waste materials. After ores are crushed and mixed with water, filtration helps recover the desired minerals while discarding the rest. This process is vital for efficient resource extraction and environmental protection. Biotechnologists use filtration to purify proteins, enzymes, and other biomolecules. Filters with specific pore sizes can separate molecules based on size, charge, or affinity. This technique is essential for producing high-purity products used in medicine, research, and industry. The cosmetics industry relies on filtration to ensure product safety and quality. Filters remove unwanted particles from creams, lotions, and other formulations. This step prevents contamination and ensures that products are smooth, effective, and safe for use on the skin. Paint manufacturers use filtration to remove lumps, dust, and other impurities from their products. This ensures a smooth, even finish when the paint is applied. Filtration also helps extend the shelf life of paints and coatings by preventing the growth of bacteria and mold. The electronics industry uses filtration to produce ultrapure water and chemicals needed for manufacturing semiconductors and other components. Even tiny particles can cause defects in electronic devices, so filtration is critical for maintaining quality and performance. Automobiles rely on various filters to keep engines running smoothly. Oil filters remove contaminants from engine oil, while air filters prevent dust and debris from entering the engine. These filtration systems help extend engine life and improve vehicle performance. Farmers use filtration to ensure clean water for irrigation and livestock. Filters remove dirt, sand, and other particles from water sources, protecting crops and animals. Filtration also plays a role in processing agricultural products, such as filtering juice or milk. Laboratory filtration is essential for preparing samples, purifying chemicals, and conducting experiments. Different types of filters and techniques are used depending on the task at hand. Mastery of filtration methods is a fundamental skill for any laboratory technician or scientist. Researchers use filtration to obtain pure samples for analysis and experimentation. Whether studying new materials, testing environmental samples, or developing new products, filtration ensures that results are accurate and reliable. It is a cornerstone of scientific investigation. Filtration is a common experiment in science classrooms. Students learn about separation techniques by filtering mixtures and observing the results. These hands-on activities help build a strong foundation in scientific principles and laboratory skills. Safety is always a priority when performing filtration. Always wear appropriate protective equipment such as gloves and goggles. Handle chemicals and glassware with care and be mindful of hot liquids or sharp edges. Proper disposal of filtered materials is also important to prevent contamination or accidents. Sometimes, filtration doesn't go as planned. Common issues include clogged filters, slow flow rates, or incomplete separation. These problems can often be solved by choosing a different filter, adjusting the setup, or pre-treating the mixture. Troubleshooting skills are essential for efficient and effective filtration. To improve filtration efficiency, consider factors such as filter pore size, flow rate, and temperature. Pre-filtering the mixture to remove large particles can prevent clogging. Using a vacuum or increasing temperature can speed up the process. Regular maintenance of equipment also ensures consistent performance. Filtration plays a role in sustainability by reducing waste and conserving resources. Reusing filters, recycling filtered materials, and developing eco-friendly filtration technologies help minimize environmental impact. Sustainable filtration practices are becoming increasingly important in both industry and research. Recent innovations in filtration include the development of nanomaterials, smart filters, and advanced membranes. These technologies offer improved efficiency, selectivity, and durability. Ongoing research continues to push the boundaries of what filtration can achieve, opening up new possibilities in science and industry. Filtration is essential for protecting human health. Clean water, safe air, and pure medicines all depend on effective filtration. Advances in filtration technology have helped reduce the spread of disease, improve quality of life, and support public health initiatives worldwide. Environmental protection relies on filtration to remove pollutants from air, water, and soil. Filters help prevent the spread of contaminants and support efforts to clean up polluted sites. Effective filtration is a key tool in the fight against environmental degradation. Space missions use advanced filtration systems to provide astronauts with clean air and water. These systems must be highly reliable and efficient as resupply is limited. Filtration technology developed for space often finds applications on Earth, improving life for everyone. Future of filtration looks bright, with ongoing research focused on making processes faster, more efficient, and more sustainable. New materials and smart technologies are set to revolutionize how we separate and purify substances. As challenges such as pollution and resource scarcity grow, filtration will remain a vital tool for science and society. Summary: filtration is a versatile and essential technique in chemistry and beyond. It enables the separation and purification of substances in countless applications, from laboratories to industries and even our daily lives. Understanding the principles and practices of filtration empowers us to tackle challenges in health, environment, and technology. As we continue to innovate, filtration will play an even greater role in shaping a cleaner, safer, and more sustainable world. Thank you for joining us on this exploration of filtration in chemistry.